Okay, so we left off talking about the equation of a wave, and I know this looks really intimidating, but once I show you what you're going to be doing with it, I hope it becomes less intimidating. But what we were talking about is we have cosine here and we have sine here. And in fact, this could be negative cosine or this could be negative sine. So the question is, when do I use positive cosine or positive sine, and when do I use negative cosine or negative sine? And that all depends on what the wave actually looks like. So if I have a wave that looks like it's starting from the top and going down, it's going to be a positive cosine that I plug in my equation. If it starts from the middle and goes up, that's going to be a positive sine. If it starts from the middle and goes down, that's going to be a negative sine. And if it is starts at the bottom and starts going up, that is going to be a negative cosine. So what does this look like when we look at full waveforms? Here we have a positive sine. We can see that it starts from the middle and goes up. Here we have a positive cosine. It starts from the top and goes down. Here we have just the opposite. On the left-hand side, we have a wave that starts from the very bottom and goes up. That's negative cosine. And here we have one that starts from the middle and goes down. That's negative sine. So let's practice a problem really quick. We have this waveform. First off, we should be able to tell, is this a positive or negative cosine or sine graph? So if I have an amplitude of 3 meters for this given graph and the period is going to be 2.5 seconds, what is the equation of this wave? All I want to do is I want to take a look. I should know that it's starting from the middle and it's going down, so it's going to be negative sine. So I'm going to grab my equation from the last few slides. X of t equals a times, notice I changed this is negative sine because of the way my graph looks, times 2 pi over my period times little t for time. All I'm going to do is I'm going to plug in my amplitude, 3 meters for A. I'm going to plug in my period for capital T, 2.5, and my answer is 3 meters times negative sine, because of the way the graph looks, times 2 pi over 2.5, because that's the period, times t. Notice that I don't change little t at all, because that's the variable that the equation is a function of. Okay, so your homework assignments are going to be one, a worksheet, Google form. You're going to be answering questions about the anatomy of a wave, and you're going to be practicing figuring out how amplitude and the period and how cosine and sine work for making a formula, creating an equation. And then you're going to be doing an anatomy of a wave activity. What you're basically doing is you're creating a cheat sheet for yourself that covers the structure of a wave, the frequency, the period, the wavelength, and you're going to be drawing it. And you're going to be defining these terms on the back of it. The purpose of this is it's not necessarily a very difficult homework assignment, but I want you to know these terms because we're going to be talking about light and we're going to be talking about sound and all these different waves. And I'm going to be talking about changes in frequency, changes in amplitude, and how that affects the sound or the light that we see. So those are your 2 homework assignments for this week. I hope you have a wonderful week, and I will see you next time.